Hello, we are back and we're going to talk about transformation. This is section 2.5. So before we get into transformations, which is basically just things that you can do with a graph to change it up, shift it one direction or the other, make it wider, make it narrower, turn it upside down. Those are all transformations that we're going to learn. How does the equation change when those visual things on the graph changes? But before we do that, I want you to look at the top of your notes. Let me blow this up so you can see it a little bit better. You hopefully printed this out as well. These are some basic functions that I'd like for you to be familiar with. The first one is the line, and this is a basic line, y equals x. If you remember in chapter 1 we spent a lot of time with lines, and if you think of this as being slope-intercept form, y equals mx plus b, the equation y equals x means that the slope is 1, so the rise over run, you go up 1 to the right 1, and you can see if you start at the origin, go up 1 over 1, you see all of these points just fall right in that line. And the y-intercept is 0 because there is no b out here. It's just y equals x. The plus b is 0, so it goes right through the origin. So this is just your basic line. And we've already spent quite a bit of time talking about graphing lines. But everything we learn in this chapter about moving things around on the graph also applies to lines. The second one is a parabola. And I think I've mentioned a time or two as we've run across parabolas that anytime you see x squared and that's the only exponent, you might have an x term, you might have a constant, but if the highest exponent is 2, then it is going to make a parabola, and it's either going to open up or it's going to open down. This one happens to go through the origin, and it's kind of like the one over here. There's not a constant there to shift it up the axis, and we're going to actually, I'm getting ahead of myself, we're going to talk about moving it up the axis and down the axis and to the right and the left on the x-axis, turning it upside down. But I want you to study this chart and just remember anytime you see that x squared, it is going to be a parabola. Okay, so from this point forward, and we're actually going to dig really deep in chapter 3 about quadratic equations, which is what that is whenever there's an x squared. Okay, the rest of these I want you to be familiar, but we're not going to dive in as deeply. But when you see them, I'd like for you to just recognize what they are. So a square root of x, and you can plot some points. Let's pick an x and we'll find the y. Plug in 0, square root of 0 is 0, so that you can see it goes right through the origin. Plug in a 1. Square root of 1 is 1, so we have the point 1, 1. Looks good. We're taking the square root, so let's jump over to 4, since that comes out even. That's a perfect square. Square root of 4 is 2, so if we go over here, 1, 2, 3, 4, do you see how that looks like? It's 2 on the y-axis, so that's our point 2, 4. We could go on out here and we could do 9, 3. It would be off the graph over here, but this would continue out and go through there. Now, it's kind of interesting. We don't have anything over here on the negative side. Why is that? Well, let's just try plugging in a number. How about -1? What is the square root of -1? It's not a real number. So for this chapter, we are not dealing with square roots of negatives. Now, when we get to 3.1, which is our very next section, we'll be all about imaginary numbers. But right now, when we're graphing on the xy axis, there are no imaginary numbers. -2, -4, same way. Not taking a square root that we don't get something that can be graphed on a real coordinated plane. Okay, cubic function, so x to the third. We could again plot some points. 0 to the third power is 0, 1 to the third power is 1. Go out here 2, if x is 2, cube that, we go way up here to 8. You see how this shape? And in fact, anytime you have an odd power, x to the 5th, x to the 7th, if that's your highest power, you're going to see a shape like this where one end goes up and one end goes down. Now, it might be reversed where it goes up on the left and down on the right. We're going to talk about when that happens. There's no bumps in the middle of this. This just comes up from the left, crosses the origin, goes up. That's a cube. If it was to the 5th power, there might be a little bump in there, so it might be kind of a little S curve. If there was to the 7th, it might have a couple bumps before the ends extend in opposite directions. If the power is even, the ends extend in the same direction. We saw that with the x squared. They both point up or they both point down. If we had x to the 4th, both ends would either go up or both ends go down. They go the same direction. So that's just a little thing to remember. Cubed root of x. Now that's the opposite of cubing it. So this is saying what number can I take times itself 3 times to get whatever's under the root sign. And so it kind of looks like this x cubed graph turned on its side, and that really is what it is. Those same points that we plotted over here, you can flip the x's and y's and we would plot them here. So cubed root of 0 is 0, cubed root of 1 is 1, cubed root of 8 is 2. And I never talked about negatives over here, but when you're taking a cubed root, you can take the cubed root or the cube of a negative. Cubed root of negative 1, well, is negative 1. If you take negative 1 times itself 3 times, you do get negative 1. Cubed root of negative 8 is negative 2. So we do get the negatives whenever we're doing an odd power or an odd root. Okay, 1 over x. And again, we could plot some points. 0 is undefined, so you see there's a hole here in 0. It never reaches. As this graph goes up toward the y-axis, it never reaches it. It just keeps getting closer and closer, but never reaching. In the same way on the negative side, going down, it will just continue to hug that y-axis, but never touch it. We do have a hole right here at 0. So let's plot some other points. 1 over 1, if x is 1, is 1. 1 over 2 is 1/2. 1 over 3 is 1/3. So you see these getting very, very small. 1 over 1/2 would be right in here. That would be 2. So it goes up there. 1 over 1/3 is going to be 3. So you can see that shape. And we have similar things happening on the negative side. 1 over negative 1 is negative 1. 1 over negative 2 is negative 1/2. And so on. So you can always get to these by plotting points. And in fact, all of these are functions. So all of these you could graph on your graphing calculator as well. But I do want you to be familiar because it does help to be able to get a start on problems whenever you kind of know what the basic looks like. And then y equals the absolute value of x. Again, plotting some points 0, 0, 1. Absolute value of 1 is 1. Absolute value 2 of 2. So this looks, on the right side, it looks like our identity linear function, right? But when we go on the left-hand side, absolute value of negative 1 is positive 1. Absolute value of negative 2 is positive 2. So that's why we get the v. Okay, so that is just kind of an explanation of these basic functions that I want you to be familiar with. It really will help you going forward. I'm going to stop the video there and come right back on the next video and talk about some of these transformations. I think this is going to be kind of cool. I'm going to pull up a program so we'll be able to visually see how these transformations work.